The following is an encore presentation of Everything Everywhere Daily. Ever since astronomers figured out that the stars in the sky are just like our sun, they began wondering if those stars had planets just like our sun. For centuries, this remained an unanswerable question. Telescopes and techniques weren't advanced enough to get an answer one way or the other. Eventually, however, astronomers developed these methods to detect if there were planets outside of our solar system, and when they did, they found them everywhere. Learn more about exoplanets, planets that orbit other stars, on this episode of Everything Everywhere Daily.
Want a website with unmatched power, speed, and control? Try Bluehost Cloud, the new web hosting plan from Bluehost, built for WordPress creators by WordPress experts. With 100% uptime, incredible load times, and 24/7 WordPress priority support, your site will be lightning fast with global reach. And with Bluehost Cloud, your sites can handle surges in traffic no matter how big. Plus, you automatically get daily backups and world-class security. Get started now at Bluehost.com.
Make this new school year an opportunity for your kids to learn important life skills with Greenlight. Greenlight is a debit card and money app for families where kids learn how to save, invest, and spend wisely, while parents keep an eye on kids' money habits. Greenlight also helps families get into their fall routine with a chores feature that lets parents assign chores and pay kids allowance when they check them off. Get your first month free at greenlight.com/Spotify. Greenlight.com/Spotify.
The idea that other stars had planets has been around a long time. As early as the 16th century, the Italian astronomer Giordano Bruno posited that there might be planets orbiting around other stars. And he was also the first person to seriously raise the idea that those other planets might have life just like Earth. It was a philosophical point for centuries because no one had any way of detecting if there were planets around other stars. There were several claims of planets having been found around other stars in the late 19th and early 20th centuries, but those claims were never substantiated. Because we had no data, astronomers were stuck speculating. The big question was if our solar system was typical or atypical. If there were other solar systems around other stars, would they look roughly like our solar system, or would they be totally different? For example, in our solar system, small rocky planets are the inner planets, and gas giants are the outer planets. No one knew if this was a rock-solid law of planet formation, or if this was just particular to how our solar system happened to develop. Imagine an alien encountering a single human being, and from that one example trying to figure out if every human being was like that one. Did we all have 4 limbs? Did we all have black hair? There's no way to know from a single data point. One concept that was floated was the idea that there could be what is known as a hot Jupiter. A hot Jupiter would be a Jupiter-sized planet, or possibly much larger, that orbits a star from a distance of about Mercury. Why are exoplanets so hard to find? Well, there are several reasons. The first is that they're really far away. And by really far away, I mean really, really far away. The closest star to our solar system is Proxima Centauri. It is over 6,800 times further from the Sun than Pluto is. They're so far away that most stars appear to be nothing more than a point of light. Planets are much smaller than stars, so being able to see them would at least be an order of magnitude harder due to the distance. The second problem is light. Stars produce light and are very bright. Planets do not give off light and are not very bright. The only light they give off is reflected light. Moreover, when a planet is between us and a star, it's reflecting all of its light away from us. The big problem is that stars are so bright that it makes it hard to see anything around it. If you've ever had a bright light shine in your face and you had to use your hand to block that light so you could see everything else, it's the same thing. So if astronomers wanted to find planets outside of our solar system, they were going to have to be clever. The first extrasolar planet which could be confirmed was discovered in 1992. It was discovered not around a normal star, but around a pulsar. Pulsars are incredibly rapidly spinning neutron stars that emit electromagnetic radiation from their poles like a lighthouse would emit light. Pulsars are incredibly regular, so much so that you could use them to set your clocks or to time events. The pulsar with catalog number PSR B1257+12 would pulse exactly every 0.006219 seconds. And as I said, it's very accurate. However, sometimes this pulsar would skip a beat, and it turned out that the times it would miss a beat were also very regular and could be predicted. Two astronomers, Alexander Volschan of Poland and Dale Frail of Canada, calculated that the cause of these skips was that there were two planets orbiting the pulsar that would periodically block the signal. One was 3 times the mass of Earth with an orbit of 67 days, and the other was 4 times the mass of Earth with an orbit of 98 days. They had discovered planets outside of the solar system. In 1994, a third planet was found around the same pulsar and today remains the smallest extrasolar object ever discovered. It's only about twice the mass of the Moon. A planet around a pulsar was indeed a significant discovery, but it wasn't a planet around a main sequence star like our Sun. That first occurred in 1995, with the discovery of a planet around the star 51 Pegasus. Two Swiss astronomers, Michael Mayor and Dieter Queloz, discovered the planet, which was indeed a hot Jupiter. The way they discovered the planet was a wholly unique method alternatively known as radial velocity, or Doppler spectroscopy, or the wobble method. If you remember back to my episode on tides, I said that technically the Moon doesn't revolve around the Earth. What is happening is that the Earth and the Moon are both rotating around the center of mass of the Earth-Moon system. The center of that system is within the Earth, but it isn't at the center of the Earth. The same is true for a star with a very large planet. As they are both rotating around the center of mass of their system, the star will have a very slight wobble. That means it will move slightly towards us and away from us as the planet revolves around it. One thing that astronomers can do with a high degree of precision is measure light. While 51 Pegasus is indeed far away, at about 50 light years, that movement towards and away from us will cause the light that comes from the star to change ever so slightly. As it moves away, it moves to the red part of the spectrum, and as it moves towards us, it moves to the blue part of the spectrum. This is the Doppler effect, and it's the same thing that happens when you hear a car with a siren approach you and then move away. The pitch of the siren will increase as it approaches, pushing the sound waves together, and then the pitch will decrease as it goes away as the sound waves get further apart. This is the same thing, except with light. Both Mayor and Queloz were awarded the Nobel Prize in Physics for their work in the discovery of exoplanets in 2019. The planet they discovered, which was named 51 Pegasus b, has an orbital period of only 101.5 hours and a mass of about 46% that of Jupiter. It is extremely close to its star. For example, Mercury is 58 million kilometers from the Sun. 51 Pegasus b is only 7 million kilometers away, which would make it extremely hot. Once 51 Pegasus b was discovered and independently confirmed, it opened up the floodgates for other astronomers. Once they knew there was something to actually look for and that the techniques worked, they began looking, and they began developing new techniques for finding these planets. Another technique which was developed was the transit method. The transit method is actually really simple. As a planet passes in front of a star, the light we receive from that star will dim ever so slightly because it's being blocked. Again, even though it's a small change, astronomers are able to detect very small changes in light. The first planet detected with this method was OGLE TR56b, located in the constellation Sagittarius. This too is a hot Jupiter with a mass of 1.3 Jupiters, and a year for this planet is only 29 days. With these new techniques, there was a flood of extrasolar planets that were discovered, and the discoveries have not stopped. In addition to the wobble and transit method, a host of other techniques were developed as well, and these include gravitational lensing, detecting reflected light, and even direct observation. In 2008, the Hubble Space Telescope found the first exoplanet by direct observation. The planet, known as Fomalhaut b, around the star Fomalhaut, about 25 light-years away, was discovered after analyzing images taken of the star over a period of years and seeing a speck of light move. Since then, there's been debate as to what Fomalhaut b actually is. Some think it might be part of a dust cloud around the star, or some other object that might just be passing through the Fomalhaut system. As more and more exoplanets were discovered, the tools to discover them improved as well. A big jump in our ability to discover exoplanets occurred with the launch of the Kepler Space Telescope in 2009. Kepler was a huge leap forward in our ability to discover extrasolar planets. It basically had one job: monitor the light coming in from over 150,000 stars to detect exoplanets using the transit method. Kepler had a 9-year run before it was retired in 2018, but during that time, it was responsible for the discovery of 2,662 new exoplanets and over 5,000 candidate exoplanets that still need to be confirmed. The next big advancement will be the James Webb Space Telescope. I previously did an episode on the James Webb Telescope just before it was launched. Since then, the mission has gone almost flawlessly, and they will soon be releasing its first images. And one of the primary missions of the Webb Telescope is to find exoplanets. In the 30 years since the exoplanet bonanza started, as of March 2022, there have now been over 5,000 exoplanets which have been confirmed, and thousands more candidate planets that still need to be verified. If you remember back to my episode on the Drake equation, one of the variables in the original Drake equation for determining the odds of intelligent life in the universe was the percentage of stars that had planets. While most of the Drake equation variables are still completely unknown, this one appears to be something close to 100%. Stars where planets haven't been observed might just have planets in orbits that are hard to see, or planets that might be too small or too far away. Most of the techniques that are currently used and the equipment that currently exists are going to tend to find the largest planets that are closest to their stars. There have been discoveries of exoplanets that have totally changed our understanding of how planets form and what type of solar systems can exist. For example, the Kepler-11 system has 5 different planets within the orbital distance of Mercury. It's been dubbed a compact solar system. Kepler-16b orbits 2 different stars, just like the planet Tatooine in Star Wars. Kepler-186f was the first rocky planet discovered within a star's habitable zone. The issue of a star's habitable zone really brings us to the big question. Can we find an exoplanet which is like Earth? A rocky planet of similar mass that's within the habitable zone of a star and has an atmosphere of water or oxygen. One planet, Gliese 581d, is known as a super-Earth, meaning it's rocky and much larger than Earth, but it's within the habitable zone. 4 planets have been found orbiting the star TRAPPIST-1 within its habitable zone. The habitable zone is the distance from a star where water on the surface of a planet could be a liquid. Too close and it would all be water vapor, too far and it would all be ice. Finding an Earth-type planet will require larger and better telescopes than what we currently have. The current methods and equipment we're using to discover exoplanets can't easily find a planet as small as the Earth. With new techniques being developed and new telescopes coming online, expect to see more and more exoplanet discoveries announced over the next few months and years. If we do manage to find an Earth-like planet, it might change everything. It would be too far away to visit with our current technology, but even knowing that one such place exists where life could be supported would have the potential to change our view of the universe and of our place in it. The executive producer of Everything Everywhere Daily is Charles Daniel. The associate producers are Benji Long and Cameron Kieffer. I want to give a big shout out to everyone who supports the show over on Patreon, including the show's producers. Your support helps me put out a show every single day. And also, Patreon is currently the only place where Everything Everywhere Daily merchandise is available to the top tier of supporters. If you'd like to talk to other listeners of the show and members of the Completionist Club, you can join the Everything Everywhere Daily Facebook group or Discord server. Links to everything are in the show notes.